Today we will talk about the first component, the resistor in the circuit diagram. Resistor is a component that hinders the magnitude of current. Then the letters of the circuit diagram are generally represented by international standards, R or PR, RN. This is used in symbols. Our international standards are like this. It does not distinguish between positive and negative. There are several common units: ohm, kiloohm, megaohm. How does it work? In our calculation, 1000 ohm is equal to 1 kilo ohm. 1000 kilo ohm is equal to 1 mega ohm. The classification of resistor is divided into several types from the resistance value. The first type is called field resistors, which is generally like this. On the resistance drawing, 0 ohm. The second type is called ordinary resistor. Its resistance is numerical. The third most common type is called precision resistors. What is its resistance? A precision resistor with a resistance between 0 ohm and 1 ohm. The fourth type is called thermistor. Its resistance is like this on the drawing. Let's talk about the second method of resistance, classified by circuit. Then the classified by circuit is divided into first type called pull-out resistor in the professional. There is also a pull-down resistor. Then the pull-out resistor is usually not connected to the ground here on the diagram. For example, it is like this. Both sides are not grounded. We call it pull-out. There is also a pull-down resistor, which is grounded at the end, which means it is a ground line. The role of pull-out resistor is limited current, so it is also called current limiting resistor. The pull-down resistor is used to stabilize the signal. The resistance is not very likely to be broken in our daily maintenance. This is usually caused by water or heavy fall. Next, we will take everyone to understand these resistors in the diagram. Next, let's take a look at what the pull-down resistor looks like in the circuit diagram. Let's take a look at this resistor. The one at the beginning of the R is not grounded at both ends, and one of the lines is a power supply line, so it's called a pull-out resistor. What does this 1 kilo mean? It represents its resistance. 1% is the replaceable error range. 116 watt represents power consumption. The following part represents its size. It is not very meaningful in maintenance. What is concerned in the maintenance is its resistance and error range. This is what our pull-out resistor. The one with K is 1000 ohm. The one without K is ohm. Read ohm directly. Then look at the three resistors in the picture. One end is grounded and the other is not grounded. We call it a pull-down resistor. The pull-down resistor do not have a unit. Read directly as ohm. This kind of resistor is not easy to break. So we have to see clearly in the circuit diagram whether it's a laptop or mobile phone. This kind of resistor is called pull-down resistor. Let's take a look at this resistor. Such resistors are all 0 ohm and are also insurance resistors. This kind of resistor is relatively easy to be broken. We should pay attention to it when overhauling. This is a key inspection object. Then look at the resistor in the picture again. It's a precision resistor. Its resistance is 0.0075, which is less than 1 ohm and greater than 0 ohm. We call this kind of precision resistance. As a current sensor, it mainly plays a role in detecting the size of current, so it is also called a current sensor. It is also relatively easy to be broken. It is mainly used in the protection isolation circuit and the charging circuit in the MAC circuit. We will talk about these two circuits later. We will focus on. Next, let's find out what our resistor looks like in the circuit board. Everyone sees this black middle and Y on both sides are our resistors. The green one you see is called precision resistor. Not used much, generally used in the charging circuit or protection isolation circuit. Other circuits are basically not used. The resistors with Y on both sides and black in the middle are generally not easy to break. In addition to the fuse resistor, remember that these two resistors are in the state on the actual circuit board. So how is the resistance measured in the circuit? To use our multimeter to measure. What about the first insurance resistor and precision resistor? We turn the multimeter to the buzzer file and see this symbol here. Measure the two ends of it with a test pen. If it sounds, it's good. It is bad if it does not sound. Regardless of the direction of the test pen, put these two ends. Ringing is good, no ringing is bad. When measuring ordinary resistance, set it to the ohm file. Put the two ends regardless of direction, and compare the measured value with the one marked on the drawing. Similar or equal is better. If there is too much difference or no value, it is broken. We need to replace it. The above is measurement of resistors. The above percentage is resistance error of this resistor. Pay attention when replacing it. So let's take a look at how this ordinary resistance is measured. Take a look at this 5572. It is 10 kilo ohm. Then we set the multimeter to the ohm gear. Find the resistor on the circuit board through to test pan regardless of direction. Let's take a look. Put it on both ends of the resistor. It is okay if the value you measure is similar or equal to the one on the drawing. Then look at the multimeter. The resistance is good at this time. Both sides also the same, because the resistance is not positive and negative. The same is true for both positive and negative. This is the measurement method of ordinary resistance. Then we find the second type of resistor on the circuit diagram, which is called precision resistor. It is 0.01 ohm. This precision resistor is green in appearance, but also white sometimes. At this time, the multimeter turns a buzzer gear to measure its two ends. Buzzing sound is good. If no buzzing sound, then this precision resistor is bad. At this time, the quantity is measured regardless of direction. This is second type of resistance, which is precise measurement method. So let's take a look at the third type of 0 ohm fuse resistors. Its measurement method is the same as precision resistor. Because it is 0 ohm, our multimeter can only on the buzzer gear. This resistor will be found on the board when the buzzer is reached. It's the same on both ends and regardless of direction. It's good to make a beat. If it doesn't make a beat, it's broken. The buzzer is sounding now, which means that the third type of resistor is good. These three types of resistors are currently on the Mac. The board shows how the three different resistors are measured and judged. Then let's talk about capacitors. Then the definition of capacitance is a container for storing electricity, which is equivalent to a battery. So what kind of alphabet are used to express on the circuit diagram? It is generally represented by alphabet C, PC, BC, EC, and divided into two categories. A metal tantalum capacitor with positive and negative poles. Its circuit symbol is like this on the circuit diagram. One side is positive and other is negative, or the following. There is also a non-polarity, no positive and negative capacitor, which is made of ceramic. This is non-polar. This is polar. So what are the units of capacitance? Common units are F, MF, μF, PF, and F. These are the units of capacitance. When you're looking at the drawing, you must read it clearly. So let's look at what this capacitor looks like on the circuit board and drawing. Let's take a look at the circuit diagram. This kind of capacitor is polarized. This section is grounded, its positive pole is not grounded, and its negative pole is grounded. We call this kind of polar capacitor. Most of the MAC are tantalum capacitors, which are easier to damage. Let's take a look at this 33 UF 20% tolerance scope replacement error range. 16 volt represents the highest withstand voltage value it can withstand. It will burn if it exceeds the withstand voltage. When we replace it, we must consider its capacitive, withstand voltage and direction, and positive negative polarity. This should be paid attention to when repairing the Mac. There are polar capacitors in this kind of thing. Let's look at the second time non-polar capacitor. The two lines are parallel. This is a non-polar ceramic capacitor. Its direction has nothing to do with actual value and measurement. It also has one section grounded and one section ungrounded. You can see that here is 2.2 μF, 20% of tolerance scope, replacement error range, and withstand voltage 2.5 volt. If the voltage is relatively high, the capacitor like this kind of grounding is relatively easy to break. But when it's broken, you can take it off without installing it to avoid damage. It is the same as other electronic products. This is a non-polar capacitor. Then we find polar capacitors on the actual circuit board. Everyone, here's the tantalum capacitor just mentioned. This kind of more positive and negative, including the above, are all metal tantalum capacitors. It is having different direction. Don't put it upside down when you change it. It will explode and damage the capacitor. If you install the wrong direction, pay attention to this. This black capacitor will also have yellow in daily maintenance. It is a polar capacitor. You can see the little yellow square. The one with white on both sides and yellow in the middle is called a ceramic capacitor. This kind of capacitor is replaced regardless of direction. The two capacitors are the same. Whether it's polar or non-polar, its characteristic and function are the same. It means that we can change it wrong. We can change polarity to non-polarity, and non-polarity to polarity. These 2 points should be noted. Although they have the same effect, they are not interchangeable. Let's take a look at the characteristic of capacitor. First, the characteristic of capacitor is pulse AC and block DC. Second, charging and discharging of energy storage. Third, pulse high frequency and block low frequency. These are 3 characteristics which come out according to the effect of their characteristic on the circuit. The first feature is grounding. The grounded capacitor is connected to ground, which has a double layer function. One of the functions is to charge and discharge energy storage to prevent insufficient power supply. It is equivalent to battery. It will be charging when the line has enough power. When the circuit voltage is insufficient, it will automatically release the electricity to supplement the power supply. This kind of grounded capacitor is in actual maintenance. If it is damaged, it can be removed and not installed. The second role is to filter out AC clutter. Because the Mac uses DC, when the circuit is working, a kind of AC noise is generated. If it is not processed, it will burn the Mac equipment. Therefore, the grounded capacitor is also called the storage capacitor and the filter capacitor. This kind of capacitor is critical and has a dual role. The second type of capacitor is not grounded. This kind of ungrounded capacitance is called coupling capacitor. It means that the signals are combined with each other. This kind of capacitor must be replaced if it is damaged. The grounded capacitor can be removed and not installed. 95% capacitor of circuit board has one end grounded. Nothing is grounded at both ends. Only one end is grounded, or neither end is grounded. So how to measure the quality of capacitor? First, the multimeter is in the bezel position. In this position, then put the test pans on these two ends, regardless of direction. sound equals bad, no sound equals okay. To be placed on both ends of the solder joint, regardless of direction. The above is the measurement of the quality of the capacitor. The multimeter turns to buzzer to test our capacitor. It has polarity. Then we put the test leads on both ends of capacitor. If the buzzer sounds, the capacitor has been damaged. Look at these capacitors. If they keep ringing for a long time, they are bad. It doesn't sound now. It's bad if it keeps on long. It's normal to sound for a while. The small one, it has sound means it's bad. The test pans are placed at both ends. It does not distinguish the direction. Put it like this or put it like this. As long as it rings, a long beat is bad, a sharp beat is good. Let's talk about how capacitance is measured. The capacitor testing does not need to look at the polarometer. The multimeter turns on the buzzer file at this time whether it is polar or non-polar. This is non-polar and our things are polar. We put it on both ends if it buzzes. This is good, no beeping, no value. This kind of beats but the value does not return to zero. The kind of capacitor is bad if it beats to zero. This is a measurement of capacitors. There are two states. One is to make no beep. In other cases, it's good to beep and have a numerical value. The capacitor is broken only when the beeping sound and the value is zero. Today we will talk about this kind of component, inductor. The first point, inductor is actually a component that can generate and induce magnetic field when energized. The second point, its structure is a component with copper wire wood on the magnetic core, which is composed of copper wire and magnetic core. The third point, when the current passes through the copper wire. It is a component that generates magnetic energy from the internal magnetic core, and then generates electrical energy from the magnetic energy. Therefore, it is a kind of electric energy to generate magnetic energy, and then generate electric energy. The fourth point, generally the four alphabet, L, PL, FL, FB, are used to indicate in the circuit diagram. Fifth point, there are two types of symbol. This is the first one, and this is the second one. Those with horizontal line have magnetic core, and those without horizontal line do not have magnetic cores. The function with magnetic core is better than without magnetic core. Sixth point, its unit is Henry. The above is the basic knowledge of inductor. Below we find out what this inductor looks like in the actual circuit board. Then we first find the first type of inductor in the circuit board, called an inductor coil. Everyone finds this kind of square shape on the circuit board. The cement color is called inductor coil. There are many more, including the row below. This clock 1, 2, 3, and 4 are all inductor coils. This kind of inductor coil plays a role of energy storage and filtering on the circuit board. The chance of damage is small, but once damaged, it must be replaced. It is equivalent to the battery, responsible for charging and discharging the circuit. So this kind of inductor is also more common on Mac. We should also pay attention to this when checking the inductor coil, which is the first type. There is also a printed circuit inductor that needs to be observed under the microscope. Because the circuit on the Apple Mac laptop is relatively small, we can only observe through a microscope. Next, let's observe the second type of inductor under a microscope. There will be these inductor coils next to the connectors, including such a small one, can only be seen in the microscope. Next, we look at the seventh point of knowledge of inductors, characteristic. The first point of the characteristics of inductor, allow DC to pass. Blocking the AC. What does it mean? When in working, direct current can pass through and prevent alternating current from passing through. The second point is charging and discharging of energy storage, which is equivalent to the storing energy, equivalent to a battery. Charge it, then it can be discharged inside. Pass low frequency, block high frequency current. This is not used much on our computer, as I understand it. Then the inductor has two main functions. The first is connected to the 8-pin field effect transistor, Q and PQ, as energy storage, charging and discharging, equivalent to the battery. As in our picture, this is the first function. In the circuit diagram, this kind of inductor plays a role in charging and discharging energy storage. And this is an 8-pin field effect transistor. This is a high side MOSFET. Here's Q, here's PQ. Charge the high side and low side MOSFET through this strip. Control the high side and low side MOSFET to be turned on, and this chip output a square wave to control the high side and low side MOSFET. The high side and low side MOSFET control the charging and discharging of this inductor, and then store electricity in the load. In the circuit diagram, this inductor plays a role equivalent to a battery, charging and discharging energy storage. And we are in the circuit diagram. Generally in the Mac circuit is very common. This is a S-pole grounding and the high side MOSFET. This is a high side MOSFET. The chip is used to control the conduction of the two transistors, in turn to charge the inductor, and control the discharge and load of inductor. Then this kind of circuit is also a lot of Mac circuit. Where do you think this square wave comes from? This kind of square wave must be measured by the oscilloscope while working. When talking about the field effect transistor later, I will focus on the working principle of the field effect transistor. Today we will focus on the inductor. Later, in the circuit diagram, we will see that this structural inductor is used for energy storage, charging and discharging. Let's use the circuit diagram to point out this kind of electricity. In the circuit diagram, this kind of inductor exists. Let's take a look at the combination of the knowledge just mentioned. Let's take a look at the inductor coil in the picture, which is store energy and filter. It is equivalent to a battery, just mentioned on the whiteboard. Then these two MOSFET are high side MOSFET and low side MOSFET. Only two of the lower ground is the ground line GND. These two are the low side MOSFET and the high side MOSFET. The upper transistor controls the charging of inductor, and the lower transistor controls the discharge of the inductor. We will talk about circuit like this later, called switching power supply, PWM power supply. It is easier to break during maintenance. The inductor is very important in the circuit. When we are repairing, the inductor cannot be broken. If it is broken, it must be replaced. Otherwise, the circuit will not work. We call the circuit a switching power supply. Later, our power supply circuit will focus on the working principle and maintenance of circuit where this inductor is located. Today, I will focus on the first role of inductor, which is store energy and charge and discharge current. Let's talk about this kind of plain circuit inductor with a relatively small volume. It acts as a kind of insurance on the circuit. Usually it is next to the connectors. This kind of inductor is relatively easy to break. So next we find the circuit diagram what the inductor next to the connector looks like. And the plain circuit inductor is next to the battery connector. In the circuit diagram, this kind of inductor plays an insurance role. It is relatively easy to break, but this kind of inductor can be jumpered when repairing. Once broken, you can short the 2 points with the tin or copper wire. It is no sign with the inductor just now. That must be replaced if it is broken. This kind of inductor that can be short jumper is also relatively easy to break. So this is our second type of inductor. Next, we use a multimeter to show you how to measure the quality of inductor. First, turn the multimeter to the buzzer gear. Then put the two test pans on the both ends of inductor and here in the buzzer to indicate good. Bad if there is no beep. No direction when testing. This kind of large inductor is in this way. How to measure the first type of large pin-circuit inductor. The beeping sound is good. You can hear a beeping sound. It has no direction. It is first type of inductor. Then I will look at the second type of inductor. The small inductor of this kind of iron is easier to break. So you can see that in this kind of circuit, the gray ones, it looks like a capacitor, but it is an inductor. Then yellow one is the capacitor. This kind of thing is inductor. You see, this small inductor test. Beeping is good, not beeping is bad. When the two parties are connected, it does not distinguish the direction when measuring. This is a good or bad measurement way of inductor. So let's now measure the quality of inductor. For the inductor, the multimeter is also a buzzer position. Put the pens on both ends. First look at this kind of large inductor coil. It doesn't distinguish the direction. Put it on both ends and make a beeping sound to indicate good. If there is no buzzing sound, it is bad. The reverse is also the same. The measurement is irrespective of pen's direction. This is the first type of inductor, and there is a small inductor of the patch which is easier to break. Let's take a look at the second kind of small pin-circuit inductor, which acts as insurance. This kind of inductor is relatively easy to be broken. The probability of broken just now is not high. This inductor method is the same, and the multimeter is also in the buzzer position. Then place it on both ends of the inductor regardless of direction. It is good if it makes a beep. If there is no beeping sound, inductor is bad. This kind of inductor is more prone to damage, so everyone should focus on checking when repairing. Next, let's explain the diode. Them diodes are also more components on the Mac circuit board. The first point, it is a transistor with positive and negative poles. The second point, its letters are represented by D, PD, DZ, ZD, LED. DPD stands for ordinary diode, and its symbol is like this in the circuit diagram. And DZ, ZD are Zener diodes. LED is a light-emitting diode. According to the order from left to right, ordinary diode, Zener diode, light-emitting diode. The third point, the unit of the diode is also ohm, but there is only one unit. It is not like a resistance that has kilo ohm and mega ohm conversion. It has only one unit, ohm, which does not need to be converted. In practice, diode has positive and negative poles. We will open the physical circuit board to find its appearance. It has a line and a mark. The marked place is a negative pole, and a marked place is a positive pole. We call the positive pole P pole, the negative pole N pole. P is positive, N is negative. Diodes are relatively easy to be broken on the circuit board, and their effect is quite large. Diodes are divided into silicon diode and germanium diode. This is a kind of metal material. There is no difference in appearance, and it needs to be measured by multimeter. The resistance of silicon diode is about 300 ohm to 800 ohm, and the resistance value are different. The germanium diode is only about 100 ohm. The appearance and function of these two diodes are the same, but they are not interchangeable. You can replace a silicon diode with a germanium diode if it's broken. You can replace a silicon diode with a germanium diode if it's broken. This value is measured with a multimeter and reaches a diode gear. Place a red test pan on the positive pole and the black test pan on the negative pole. Don't reverse it according to this value to judge it. If you can detect it, the diode has been damaged. Then let's take a look at how to find the diode on the circuit board. Then you see that our type of diode is a diode on the circuit board. The violet place is a negative pole, and the unviolet place is a positive pole, also called P pole. Then we measure the silicon diode and germanium diode with a multimeter. You see, this is also a diode. This side is the negative. Then use a multimeter to measure whether it is a silicon diode or germanium diode. Let's take a look at the multimeter. When the multimeter is in the diode mode, this icon is displayed. After choosing the gear, put the red test pan on the positive pole of the diode and the black test pan on the negative pole of the diode. Remember this, don't let it go. At this time, we look at the value of the multimeter. Look, don't put the test pan upside down. Put the red one on the positive pole and the black one on the negative pole. At this time, we look at the value of the multimeter. Let's take a look. 750 ohms. It is between 300 and 800. We call this kind of silicon diode. Conversely, the diode has no value. Let's measure it and take a look. Exceed or not does not exist. If it exceeds 1000, don't care about it. If it exceeds 800, it won't be counted. You can make a mistake. Its normal value can only be placed on the positive pole of the red test lead, including this diode. You can see the diode below. The red test lead is placed on the positive pole, and the black test lead is placed on the negative pole of the violet place. At this time, let's look at the value displayed by a multimeter. Don't reverse it. 380 ohm as a silicon diode, including other diodes, are also measured in this way. Just now, what we measure on the circuit board is the judgment of the diode. Remember that the test pan cannot be reversed. What kind of situation should we note? The red test lead of the measuring diode is placed on the positive pole, and the black test lead is placed on the negative pole. If it is measured during maintenance, its resistance is less than 60 or higher than 100. Or 1, also called infinite, OL. 1 is no response, not 0.001. OL is displayed on the multimeter. That is to say, these three situations are bad when appearing on the multimeter. When replacing, it should not be reversed, and the positive and negative poles should be distinguished. This is a characteristic of diode. But there are more silicon diode than germanium diode on the motherboard. Let's talk about the characteristic of diode, which can be summarized in some words. For work conduction, reverse cutoff. Turning on means working, and turning off means not working. What does it mean? When working, the current can only go from positive to negative, and cannot from negative to positive. Use a characteristic of diode. What is its use? What are the functions of diode circuit? The first one is not grounded in the circuit diagram. The ungrounded diode plays a role of rectification. Rectification means to convert alternating current into direct current. Since both mobile phones and computers use direct current, a kind of AC clutter is generated when the circuit is working. It turns it into a direct current through this ungrounded diode. Wait a minute, we will find out what this rectifier diode looks like in the circuit diagram. This is the first function, the second is grounded. You'll find this kind of grounded diode in the circuit diagram, positive and negative grounded, GND. What role does this diode play? Protection. Then it prevents excessive voltage, excessive current, and burnout. Normally, this diode is not working. Once the current and voltage are too large, the excess current and voltage will be put on the ground. Avoid burning other equipment. This kind of diode is also called protection diode. So tell you one more thing. This kind of protection diode can be removed and not installed if it's broken. But this kind of rectifier diode is broken. Take it down and replace it. Next, we find out what two different diodes looks like in the circuit diagram. So let's look at the first type of grounded diode. This and this. It is grounded at one end. You can see this ground wire. So because the diode is grounded, it plays a protective role. It prevents the voltage from being too high and current from being too high. It is inside. At this time, please pay attention. This is a protection diode. Why do I need to draw two? On the surface, it's a one diode, but a composite diode. There are two diodes inside, so the effect will be better and more stable. This is a kind of protection diode. But this kind of diode can be removed and not installed when it is broken. Let's look at the rectifier diode again. Let's take a look at this ungrounded diode. D8100, such as this max. Then this diode plays a role of rectification. When you have alternating current, it becomes direct current. Once this kind of diode is damaged, it must be replaced. Why? Because both ends are not grounded, it connects two lines. So this kind of diode called rectifier diode. In other circuit diagram later, as long as you see that it's not grounded, it is rectifier diode. Grounding is a protection diode. This is the knowledge point of the diode. Next, let's talk about how to measure the diode. First of all, we have to adjust to the diode gear and look at this gear. Then connect the black test pan to the black end and the red test pan to the other end. There are values here, and there are values that prove to be normal. It is abnormal if the beeping sound has no value. There is also a saturation. The black logo is sometimes white. But we also use the black test pan to touch the end, and the red test pan to other end, to see if the diode has resistance. Okay, let's test another one and take a look. Connect the same black test lead to the black end and the red test lead to the other end. Okay, you can see that this is the same. Here is the resistance value. There is a diode value. It proves that this diode is also good. This is how the diode is measured. In this lesson, let's talk about crystal oscillators. The first point, the crystal oscillator in the circuit is a component that can vibrate and generate frequency when energized. The second point is the latter are represented by S or Y. The third point is unit symbols like this on the circuit diagram. Fourth point, it has this kind of units: hertz, kilohertz, megahertz. Its conversion formula is 1000 Hz is equal to 1 kHz. 1000 kHz is equal to 1 MHz. Fifth point is rails provide a clock signal for the chip. There is not much chance that the crystal oscillator will break on the laptop, and the number is also relatively small. It has several kinds of chips in the Macs. There is one on EC, which is 32,768 kHz. The second one is for PCH, which is also 32,768 kHz. The third one is the network card chip, which is 25 MHz. The four discrete graphics cards are 27 MHz. The above are the four common crystal oscillators on Macs. And the crystal oscillator of EC is to read the EC clock signal. Which crystal oscillator does not work? The chip does not work. Let's plot it out on the circuit board to show you. So let's take a look at how many crystal oscillators Mac has. From here, there is a crystal of EC. The second is the network card crystal oscillator. The third one is for PCH, the crystal oscillator of sound bridge. The next one is close to the graphics card. Here's the graphics card crystal oscillator. Which crystal oscillator does not work? The corresponding chip does not work. The positions of different crystals on different motherboards are different, but the principle and appearance are the same. Below we are in the circuit diagram, for example, showing the crystal oscillator for everyone to see. Y2600. 32,768 kHz is its operating frequency. This is a symbol of the crystal oscillator. Let's take a look at the two capacitors connected to the crystal oscillator. They play a filtering role. These two capacitors will be repaired in the future as long as the capacitor connected to the crystal oscillator is special. It is also grounded for filtering, but it cannot be less. It filters the clutter of the crystal oscillator, so it is 32,768 kHz and 25 MHz or 27 MHz will be encountered in the circuit diagram in the other places. Let's take this area as an example. When the measurement is good or bad, we also test whether there is electricity on the capacitor to determine. Let's take a look at this 25 MHz crystal oscillator. It has 4 pins. 2 of the crosses are not used. The ones that really work are pin 1 and pin 3. There are 2-pin crystal oscillator or 4-pin crystal oscillator in the Mac. If you encounter a 4-pin crystal oscillator, then the 2-pin crystal oscillator will not work. We only need to look at the first pin and the 3rd pin. Then this crystal is connected to these 2 capacitors for filtering. Although these 2 capacitors are also grounded when we repairing. And the filter capacitor which connected to the ground that we taught previous lesson can be removed without installing. However, if the 2 capacitors connected to the crystal oscillator are damaged, they must be installed. The parameter here is 20p at 5% error rate. This parameter of withstand voltage must be taken into consideration and should not be changed at will. First of all, it must be replaced, not at will. It's necessary to see the parameter clearly. This crystal is a 25 MHz crystal. Therefore, pay attention to this resistor when overhauling, and they should not be dropped or damaged. The quality of the crystal oscillator. When the power is turned on, it is necessary to measure whether there is a voltage and waveform on the capacitor to judge. Different crystal oscillators have different operating voltage. We will explain in the detail when we talk about the circuit in the detail. So how is the quality of the crystal oscillator judged? The first point is the voltage method. First, power on the motherboard, and then set the multimeter to the voltage range. The black test lead is grounded at the negative pole, and the red test lead is placed on the connected capacitor. It is better to measure the voltage different. The 2 voltages cannot be equal, and there must be electricity. It has 2 capacitors in the picture. This kind of voltage and this kind of voltage cannot be equal. The voltage difference between the 2 capacitors cannot be equal. If they are equal, the crystal oscillator is broken, and if they are not equal, it is good. This is the first method. There must be a voltage difference. If it doesn't, it is broken. In general maintenance, use this method a little more. There is a second method called wave method. We need to power with an oscilloscope and use an oscilloscope to measure where there is a square wave on the capacitor. Its waveform looks like this on an oscilloscope, called positive circle wave. If this kind of waveform appears, it means that the crystal oscillator is normal. If you are a professional master, you use a second method more often. In practice, the voltage method is used more because the crystal oscillator is not easy to break. Many shops do not have an oscilloscope and use voltage method to check. This is the quality of the crystal oscillator.